Good morning. My name is Tom Schmidt, and I'm the Senior Vice President of Sales for APC. We're pleased to welcome you this morning to our webinar, hosting two great speakers, Dr. Jose Sanchez-Vizcaino and Dr. Joe Crenshaw. I wanted to take a few minutes to talk about housekeeping for the webinar. We thank you very much for your attendance today. Please add any questions or comments that you may have into the chat feature of Zoom during the presentations. We will direct these questions to the appropriate speaker for answers at the conclusion of the presentation during the question and answer period. I wanted to take a few minutes and just introduce APC. We were established in 1981. We're a global business that's headquartered here in Ankeny, Iowa, the central part of the US. We are the world's largest producer of spray-dried functional proteins. We have global research, marketing, and selling into the production of livestock and agribusiness industries. We do have a dedicated commitment to research with over 600 published peer-reviewed studies focused on various applications in the global market, heavily weighted in the swine and biosafety areas. We do have 17 manufacturing facilities located globally. These are dedicated to either porcine or bovine production of functional proteins. And these are strategically located to ensure a timely supply of products to all regions and the industries we serve. Thank you. With that, I want to introduce you today to the two speakers, Dr. Jose Manuel Sanchez-Vizcaino. Dr. Sanchez-Vizcaino has more than 240 scientific publications in high-impact international journals. He is the author of 47 chapters in internationally renowned books. He has been the IP of more than 150 national and international competitive research projects and the director of 34 doctoral theses. He has been awarded the Medal of Merit from OIE. His current scientific interest is focused on the study of the epidemiology and preventative medicine of infectious diseases of animals, as well as the development of new diagnostic techniques, new generation vaccines, and new strategies for their control. He is currently the coordinator of the EU vaccinia project for a safe and effective vaccine against ASF-DIVA. Our other speaker this morning will be Dr. Joe Crenshaw. He is the Vice President of Technical Service for APC. After earning his PhD in swine nutrition, Dr. Crenshaw embarked on a career spanning 35 years in the swine industry, including teaching, research, and development, and private consulting in agricultural development. At APC, he has over 20 years of experience providing technical service for customers. Dr. Crenshaw conducts product development and application research with an emphasis on the safety and efficacy of spray-dried plasma. He has been an invited speaker at numerous global conferences and has authored more than 100 publications. With that, we will start the webinar, and I'm pleased to turn it over to Dr. Jose Manuel Sanchez-Vizcaino for his presentation.
Okay, can you hear me now, everybody?
Yes, very well, very well.
Okay, beautiful, beautiful. Thank you very much. So thank you very much for the invitations to share with you all these presentations and to have a good time with all of you. I really thanks very much the invitations. And as our speaker told already, I'm going to tell you how is the situation of ASF around the 5 different continents and what can we do in case that we want to protect it ourselves or what will be our future. So this is the agenda that I prepared for you today, to review the global situation of the ASF, to review the current risk, because the risk is changing almost every day. What can we do to reduce the risk of ASF introductions? How can we protect ourselves and what we need? What is important of the early detection that is very critical, the early detection to have a good diagnosis, as well as a good contingency program. How is the ASF vaccine current situations? I'm going to tell you about, in general, how is running the vaccine for ASF, and in particular of the projects that I am the honor to lead, is the European Union project for the vaccine. And finally, to answer your question or comments. Again, thank you very much for the invitation, and good morning to everybody. So I am working in African swine fever since 1978. And this is the worst situation I never saw in my life. Never I saw the 5 continents affected with African swine fever like now. So since the 2007, that probably you remember, was the last exit of the virus from Africa. In particular, they live in this occasion from the East Coast of Africa. They touched Madagascar, is a boat. They went by a boat and they went to the Caucasus. So that's in 2007. So since 2007, already 5 continents are affected, more than 50 countries, and at least 8 epidemiological scenarios different. So this is the real situation. The last continent affected, as you know, is very near to all of you. And this is Dominican Republic and Haiti. So the virus is already there. So in general, I have to tell you that in 2007 was the last time lived. Now we are 2021, so 14 years, and the disease was not stopped at all. It's a disease that is spread almost every day. We have new areas affected. And one of the reasons why I think that's happened is for 2 reasons. One is that the disease is underestimated, and the second is that it's not well known. In particular, the mechanism of transmission, as well as the resistance of this virus is very, very resistant, as you're going to see. So let me very quickly to show you how are the different continents affected and how is the situation. It started for Africa, but as you know, was where African swine fever was festival described. So we have 2 different scenarios. One is the East and South Africa, and the other one is the West Africa. West Africa will be relatively easy to control, but in East and South Africa, the situation is quite different. That is the area where it has been reported for first time in Kenya in 1921, African swine fever. It's also the place where all the different viruses that we characterize as genotypes, we have a total of 24 genotypes already. All of them are living in this area. And also in this area are living these guys that I show you here. This is the bush pigs, this is the Phacochero, and also they're living with this vector. This vector is Ornithodorus, but in particular Ornithodorus mubata. These animals have the capacity to infect themselves with African swine fever, but the virus never reached the virus higher than 10^2. So these animals have one type of tolerance to the ASF infections because they can deal with the virus and don't have lesions that put in trouble their life. But they are carriers of the virus. With 10^2, they still have the virus around the body. So what happened in this situation? In these situations, these vectors, the Ornithodorus mubata, have the possibility to bite one of these animals with 10^2 and amplify the virus themselves because the virus is multiplied in this Ornithodorus, and they move to 10^2 to 10^7. So that is a high amount of virus, as you know, and they are able to infect it not only wildlife, but also domestic life. And this cycle is what is happened already, that continuously are all the virus around and all the time infected wild and domestic, thanks to this vector. So this selvatic and domestic cycle is coexistent, and this is the reasons why we have to stop also the disease here, unless that we don't want to have more release from this place of the world. So this is one of the biggest problems that we have. The situation in Europe is quite a little more normal, not too much trouble like in this other area. But in Europe, we have two different scenarios that are completely different as well. We have in the East countries of Europe, including some of the European Union, we have most of the infection in domestic here in red. So our infection is in domestic with also wildlife infected. The reasons why here is very frequently to have that is because in these areas, there is a lot of farms with very low biosecurity and also backyard production. So that is the reasons why here is quite complicated, as you're going to see a little later. Now we also have the west area of the European Union where most of our countries are located, what is exactly the opposite situation. We have a lot infection in wild boar and blue and relatively few in domestic. And I'm going to explain you why this domestic still have trouble. I'm going to show you and why wildlife is so complicated as well. So the good news that we have in the European Union, where you see many, European and Europe in general, as you see, many countries are affected, starting in Georgia in 2007, as I mentioned to you, and the last was Alemania, Germany in 2020. And the good news that we have recently, some of them a little longer in the time, was Czech Republic, that they eradicated totally the disease from their territory, as well as our colleagues from Belgium. Both of these countries did a fantastic job, and they are already free and declared by OIE as a free. And also we have very soon, I hope, the Sardinia. They started in 2015 to 2020, a beautiful eradication control program. They found where the virus has been normally stable, that was in the free-ranging pigs. And since the last 2.5 years, is no outbreak at all in domestic or in wildlife. So I hope that soon it's going to be declared. So the situation in our territory is between 2014, because this is where the infection started in the European Union in the 2014. And we have between 2014 to 2021. So in this 7 years, we have already at present 37% of the European countries affected. So 10 of 27, and are affected with African swine fever in domestic and also in wild boar. In domestic, as you can see, the figure are very slow and very small, 5,353 domestic farm affected. And wildlife, we have a big amount of infection cases, notification of cases, 380,875 wild boar are affected. So as I mentioned at the beginning, our real problem at this moment in the European Union area is the 87.9% of the wild boar against the 12.1 in domestic. What is the reason of that? What is the reasons? The reason is that wild boar is in all the different areas of the European Union. We have, of course, a lot of more in the natural areas, but still the number of outbreak there is 64%. So the virus is already in the natural areas since a long time ago, and still in a very high proportion. But if you move to the agroforestry area, in the agroforestry area, you found that still we have a 20% of outbreak of wild boar. So that means that the contact in the agroforestry areas with the wild boar infected and the domestic is very high. But even in the agro-urban area, we also have outbreak of wild boar. So that's prove you that the wild boar really have a very large distributions in our territory that affected from the natural areas to the agroforestry areas as well as agro-urban areas. So of course, the more number of cases of wild boar affected is in the natural areas, but these two are very important, and these are the ones that created trouble in domestic farm. So if you look now this summary, you can see that in the case of wild boar, we have, as I told you, 68.1 in the natural areas, 11 only in domestic. But I said only, but this is also important to take to take account, because 11% of domestic affected in the areas of natural areas mean that we have farms in the habitat of the wild boar, and that means that it's going to be very difficult to protect this percentage of farms. So we have to think in on the relocation of this farm outside of the natural areas. In the agroforestry, as I mentioned to you, we have a 30% in wild boar, but 80%, of course, this is normal in domestic, and in the urban areas, we have a 2% on wild boar and a 10% of domestic. So the important here to detect it, to summarize, is the biggest problem we have is wild boar, but we also should have a little information and to probably change the location of this farm and this area, the domestic one. And here we still have to increase security in some of the countries, as I'm going to show you a little later. So this is the summary that I already show you, but in picture is 68, 11, 80, 30, 10, 2. So now we are moving to another area where it's really very complicated, the situation in here. And this is due to several factors. One of them is that they started and they published in 2021, they found lower virulence ASF strain circulating in Africa. They also, they at the beginning, they thought that that's kind of, because there was mostly mutations, could be probably due to mutations, due to the virus that infects so many million pigs, and that could be the situations. But later on, they found, a little later, they found that they also found 7 genes deletion virus circulating in the area, but is not probably very much related with natural mutations and more with some kind of human deletion genes. But later, even is getting worse, because they are, at the beginning, there was only circulating virus from genotype 1, but now they found also viruses from genotype 2. So the situation at this moment in Asia, in particular in China, is where I am describing all these things, particularly in China. The situation is very complicated. As you see, this is all the countries affected already. From 28 countries, 16 are already affected. And you can see that China is really very much affected. There's no regions with no ASF at this moment. Other countries as well, including some of Oceania as well. And as I mentioned to you, they started describing attenuated virus isolation in 7 provinces and the second half of the 2020. At the beginning, by mutations and deletion of the CD2. So that could be by natural mutations. But later on, they found 7 genes deletion viruses that was circulating in these 3 provinces. That means that it's very difficult to think that the natural mutations make 7 genes deletion. So in this situation, they also find that this isolates was not hemoabsorbing, that as you know, the not hemoabsorbing are lower virulence, but they still have transmissions. Also, the incubation periods were longer, and they have partial death. So even that is attenuated, the death is still there, and subacute and chronic form. So they complicate also the situation to detect the disease in an early point of view, because the chronic form of the disease is more complicated than the acute or subacute, because the lesions in chronic are a little more complicated to link with ASF. So that is a complication for our colleagues from China, for all the farmers in China, but also the running so many strains different running in the country is worse for the rest of the world as well. So this is where they found more recently, in these areas that I have here in pink color, they found in these areas not only the genotype 2 viruses and virulence and now attenuated that I mentioned already, they found these new viruses that belong to another type of genotype, is the genotype 1. And these viruses are the ones that has been in Portugal, in Spain in the past, still in Sardinia. This genotype 1 is not the ones of the virus that is circulating now in Europe and is not circulating in other places. So how they found that? They found that what they call probably ASF fake vaccine in 2019, they put the label, this vaccine as label from Harbin Veterinary Research Institute, but absolutely was not real, was illegal. So this vaccine are making a lot of trouble. I don't know where they obtain this virus that they from genotype 1, because are very, very well-known viruses are present in many, many laboratories. I don't know how they found it, but they found it and they produce this vaccine that are creating a lot of trouble. Even they announced in the website the sale of this vaccine, you can see here. So this is also complicated, is going to complicate a lot the fight of our colleagues, our Chinese colleagues against ASF. The other things that also surprised me, at least to me, very much in Asia in general, and in particular in China, is that they have a very high concentration, as you can see here, a very high concentration of wild boar, but they don't report it too many outbreak or too many cases in wild boar. So look like they still don't realize that the wild boar are terribly important in the transmission of ASF and also in the using as a reservoir of the virus. You look the color that we have in wild boar that is high, but not as much of the color that they have in Asia. And we have a lot of trouble, as I mentioned to you before, and here in Asia, they look like they don't have too much trouble if they declare only around 9 to 10 cases in wild boar. That's also surprised me quite a lot, because our model, we make a model to evaluate how much will be the density of the population. And as you can see, it's relatively very, very high in all this area. So that's mean that if they play the important role that is played in the wild boar in Europe, they're going to have quite a lot of more trouble in the future. So in China, we can summarize that the main risk factor that they have is by education or traditions. That is that some people, especially in the family farm, as well as in some backyard farm, they buy blood and they mix the blood with feed, and they increase the protein with the blood to feed the animals. And also they use soil feeding by traditions from restaurants, from houses, etc. Some infected or carrier animals can go inside of the slaughterhouse. Infected vehicles has been found. Unidentified pig transportation has been detected. Low biosecurity, in particular in these two places, family farms and backyard. Also, they have a very wonderful high biosecurity farms in the industrial part, but in these other two, family and backyard, very low. No poor poor compensations for farmer affected. This is a big mistake, because when you don't pay to the farmer that they have or they get ASF is a problem, because most of these people, they will try to sell as much as possible to not lose everything themselves. So the no compensation in many places that I has been working in eradication and control, I found that no compensation is really a big problem to never finish with the disease. They also have already attenuated the strain circulating, not only from one genotype, but also for the genotype 1, and with a very attenuated strains or isolates, and also a high population of wild boar, but that still has not been, in my opinion, probably correct evaluated from the power of this animal, the wild boar, in the keep and transmission of the disease. So you see, these two things are terrible to use blood because, one again, I would like to tell you that just a single drop of blood have more than 3 million copies of the virus. And so that's mean the powerful that the blood has and the transmission. So what they have in summary is that there are a circle of circulating virus between infected pigs, products infected, and swine feeding again, that they are creating this problem that is difficult to stop. I also want to mention a little about the situation that you have more closest to you, is the African swine fever in Haiti and Dominican Republic. So in Dominican Republic was the first to declare ASF presentation, but they really detected the disease very late. So very late. So, but the time that they declare the disease, they have already a very important spread across several provinces, and that they continuing in the time. They have many backyard already, and also some of them using swine feeding as a very popular type of feed the animals. They start initial problem with the diagnosis at the beginning. They have initial problem with laboratory diagnosis. Now it's running very well, but at the beginning they have trouble. It's a matter of fact that the diagnosis was done, the first diagnosis, another has been done out of the country. They have a border that is very permeable with Haiti, and Haiti, as you know, have a lot of trouble at this moment with the earthquake, with the killing of the president, with a lot of mainly pig backyard, etc. So they have many difficulties. So the situation so far is not a very strong stop of the disease. They continuing moving, probably a little slower, but still moving. So if they continue like that, they will run to be an endemic countries for a while. So how can we do to be protected? What are the most important point that I recommended to all of you? The first thing is to know very well our enemy, and in particular, the main mechanism of transmissions, and be aware of this kind of risk for ourselves. I mean, for our risk, for our own risk. Review our biosecurity, our early detection for ASF, and our contingency program. This is a very important recommendation because it's very important to see if our veterinarians and farmers will very easy detect the disease, or at least suspect about, or to have a suspicions about the disease in their country, as well as a specific good contingency program that can be affected different areas of the countries, of American continent countries. Identify the possible clinical signs and clinical lesions. I mean, clinical signs and lesions are very important because this is the base for an early detection. If we don't detect the disease on the farm, if we don't detect the disease or the idea, the potential presence of the disease in the farms, it's very difficult to stop the disease easily because the disease is going to spread very quickly. And by the time that you're going to really detect that you have ASF in one area, you're going to see that many farms are affected. So it's very important to review the clinical signs and lesions, also to have an effective laboratory diagnosis, and a good and specific surveillance and contingency program in each country. This is very important, and especially specific of each area, and adapted to the different epidemiological production system, etc. I'm going to show you a little how difficult is the virus. This is about our enemy, the virus, ASF virus. First of all, is the most complex virus that is still no one more complex than this one. They have 170 to 190 kilobases. So it's a very large virus. 170 genes, only in genes they have 170. You know, there are viruses that are creating us many trouble with only 10 genes, with 20 genes, with 35 genes. This had 170. We still don't know well the complex structure of this virus. Still, we don't know what is the actions or what is the missions of some of these genes. We still don't know, or we don't find yet a very clear proteins that induce neutralizing antibodies. We found immunity, but not these neutralizing antibodies that, as you know, is very important for viruses in general to block the infection. Also, the virus have a great genetic variability. So that means that there are many different viruses. And because we don't have significant amount of neutralizing antibodies, we cannot classify the virus for serology and different neutralization system. We have to classify the virus and genotypes that are related with changes in one of the most stable protein, little changes in this stable protein to classify the virus and the different genotypes, but not in serotypes. And serotypes are very important in protection. So to study, for example, in our case that we are working a lot in African swine fever vaccine, we have to study the cross protection in vivo because we cannot do in vitro for the lack of this, a good test to evaluate cross protection for the lack of neutralizing. So this is creating trouble, as you know. So the classification of 24 genotypes are based mainly in one protein that is not related with protection, not either with virulence. So don't confuse genotypes with serotypes when we talk about African swine fever. Now, the transmission route in African swine fever are quite a lot. We have direct route from domestic or wild-born affected animal. We also have the vector, as we saw with the African vector. This is a European one. This is Ornithodorus erraticus, also amplify the virus, but also by movements of, different products like vehicles not disinfected, by birds, by humans, but many ways. But the most important that is affecting in the history of ASF is the infection through soil feeding, through products, the animal eat products that has been produced with infected materials, with infected meat, and the virus is so resistant that they keep in this product. Only if you cook the product, if you treat it by temperature, high temperature, the products that are not affected by temperature, not treated with high temperature, are infected, except the ones that is salty, the one that is treated salty, like the Iberian ham or the Parma ham, that we have a lot of studies that prove that with the period of incubation of the ham with the salt, they inactivated the virus. And that is the only product that can be not resistant and not infected in the product. The rest of the products keep a long time. So that means that the best way to spread the disease is by plane and by boat, not the commercial train or plane or boat, because they have a special system to treatment the garbage, but with a small airport, private planes, and also boat for, with containers that they have a different system. All these are very, very dangerous. So at this moment, the biggest danger that we have in the transmission of ASF is the big amount of infected products that we have around the world in many different positions and countries. This is the most important. But don't forget, it's also in any surface that has been not well disinfected. The only good advantage I can tell you about that is that African swine fever is not too efficient by aerosol transmission. And of course, a lot of less than foot and mouth, PRRS, or classical swine fever. So blood is an important issue. It's important to remember when you go hunting. It's an important, this hunter, for example, it's important when you do a domicile, a product from the family for parties, or when you have meat that became from animal and has been not treated by heat system. Why? Because, you know, this is a erythrocyte. Here is the virus. The virus attached to the erythrocytes. So that's why in blood, the concentration of virus is very, very high. But also is resistant in other environment. In blood, 4 degree, a 4 degree, 18 months, also a 4 degree, 110 days, and chill meat, also 1,000, a minor 20. So this is the way how is the resistant all over and many things, in many places, in many products, and in many surface. Like for example, in a pig pen, can be for a month. It is not disinfected properly. So this is how the virus resisted so much. Also, it's very stable in the environment, and it's easy to find it near the water because, you know, many animals came to drink water and they have feces, and in the feces, the animal release the virus, the infected animals. Also in carcass, and the carcass can be for long period of time. And if it's under degrees, like 3 or 4 degrees or 7, even for longer period of time. And this is very important you keep in mind as well. Now, what is, in my opinion, at this moment, the most danger potential introduction of the virus into an area, into a farm, into a country? How I think it's going to be the easy way. The easy way is going to be by the use of soil feeding, even not in farms, could be that people buy some product or bring it from infected country, some product, and they go for a picnic, and later they release the leftover in the picnic area. And in the picnic areas, you know, the wild boar are expertise, a high expertise to open the places and, you know, the container and take every kind of garbage very easily. So this is a way, so there will be an amplification in wild boar, and later from wild boar, they can go to domestic. That is one possibility. The other possibility is that they in countries or in areas where they use the soil feeding directly in domestic one. So with this domestic one, they're going to enter the virus. Here, the early detection is not going to work at all. But there are many things in contact between domestic areas, you know, people that buy or sell things on both sides, or track, or people that buy very cheap here and sell the animal in another places. So the entrance by backyard production is very high as well. So this is for me, the two main introduction. Of course, live animals is important. Of course, there is other mechanisms, but these two are in my opinion, at this moment, the ones that are representing the higher risk for the transmission. So we have, of course, be carefully with the vehicles, including the owner ones. That is important. We're going to now review very quickly the acute and subacute form from the clinical point of view, as well from the lesion, as well as for the lesions. So in wild boar or in domestic, what you're going to see is fever, anorexia, fever high, 22 easily, anorexia, skin hemorrhagic, breathing problem, digestive problem, incoordinations, even some abortions. If it's a pregnant place, there are going to be abortions because the fever is so high. So in the skin, you also can see this erythema in many parts of the body. We're going to see a little more in a few minutes. Also diarrhea, sometimes with blood, you know, melena, they can have that, and epistasis once in a while. Also in edema in the párpados, edema because it's, you know, they don't have good erythrocytes because of the hemorrhagic that the animal have. The lesions that you're going to have more is fever. I mean, not the lesion, but the fever can have the following lesions: spleen, large spleen, kidney with hemorrhagics, lymph nodes is one of the most significant one. Many lymph nodes are going to be affected, sometimes with like congestions, other like clot, like blood clot, kidney, less than the other two that I mentioned, but petechias in the medullary and cortical area, hydrothorax and hydropericardia. Hydropericardia is very common. The reasons why there is so much liquid and so much hemorrhagic is because the virus is not only replicated in leukocytes and in macrophages, but also is replicated in endothelial cell. So in the endothelial cell, they induce this type of liquid and this type of hemorrhagic that we see here. Look at these lymph nodes. Sometimes it's like that. They don't look like even a lymph node, look like a clot of blood already. And the intestine also with a lot of hemorrhagic. You see also pneumonia and also hydrothorax. You can also find hydrothorax, pneumonia. That's why many people confuse sometimes this disease with other. The splenomegaly is a very, very common lesion in African swine fever. You will see it easily and also very dark. The lymph nodes is fantastic. The lesion is, you look at this lymph node, it's unbelievable. So if you open and you see several lymph nodes, you have to think in an ASF for sure. And if you also have petechias, you have a splenomegaly, you know, you have to, festival of everything, be sure that it's not ASF. The hydrothorax, as I told you, yeah, they can be more or less blood with, you know, with blood, but hydrothorax is very common. Hydropericardia as well. Hydropericardia, yeah. Hemorrhagic on the intestines, you have outside, inside, and the mucous. You can see it, petechias all over. Okay, this is again hemorrhagic, splenomegalia, hydropericardia. And in the acute form, in the attenuated and chronic form, the situation is very complicated, it's more complicated. You only see some lesion problem, this type of lesion problem, and you very more frequently, this swivel and this, you see this kind of articulations, this is more frequently. But this is the only thing, this nothing compared with the other. The animals are surviving more, most of, some of them, not most, but you know, between 1 to 4% to 3% could be carrier of the virus, and they created a lot of more trouble for detection and for stop the spread. Now, the sample to send it to the laboratory, the most important are blood and serum, lymph nodes, spleen, lung, and kidney. Also, the diagnosis can be established in PCR as well as for antibodies detection in oral fluid as well as in feces. We also described it very recently a sponge that can be good for evaluation in surface, including the animal surface, but also in one farm or in one vehicles that you want to be sure that the virus is not there. So, and the advantage of this system, because of the mix of alcoholics that we have, is that once that you wet the sponge and you pass through everything and you put again the sponge in the bottle totally inactivated the virus. They keep the DNA active, but not the virus. So it's a very safe type of sample to send in anywhere or everywhere. This is how to prepare. It's very easy, very simple. And as I told you, not even the first part of the PCR that you know is the extractions that are always infected in most of the sample. And this one you can do in a regular laboratory with no trouble. So the laboratory for diagnosis is fantastic. We have a fantastic technology for all the different virus laboratory. For PCR, for virus detection, the most common is PCR because it's quick, it's very specific, it's very sensible. And so this is the ones that we use more. Of course, the first case of one positive one should be also virus isolation. And the virus isolation is in leukocyte or macrophages to make the final report. And also we have fantastic tests for antibodies detection, like ELISA, like in Western blot, like immunoperoxides, many tests that are working with high level of sensitivity and specificity. It's important to remember in African swine fever that the early detection is going to be with a big amount of virus. So that's mean very low CTs of the PCR. And they're going to keep for quite a while period of time, but later they're going down. And when they're going down, most of animals became negative, but a few have a sporadic viremia. Sporadic means that it's not permanent, but once in a while, the virus went to the viremia as well. So, and in general, the detection for ASF, if it's an early detection, should be used at the PCR as a best election of the virus. But if you have a high, a high symptom or lesion for African swine fever and your PCR is negative, I recommend you to do also antibodies and of course to repeat the PCR with other samples. I think this is very, very important to keep in mind because antibodies is exactly the contrary. They keep for longer period of time. So what are the problems that I found more normally in areas that are not used to working or to show African swine fever lesions? Well, the wrong surveillance program, more or less, is not a good adapted surveillance program for areas that are not familiar with ASF. The late detection in field, that is very important. There is no good training of veterinary services or farmers. That's why the detection is very late. No good or incomplete laboratory diagnosis. They only do PCR, but don't do antibodies, or they do antibodies and no PCR. The low biosecurity by backyard, especially I insist to tell you that the no compensation is really a big problem. It's really a big problem. Now, the specific contingency program is very important. So in most countries, they have a very good contingency program. Compensation is important. And of course, a wonderful collaborations between the private and the public together. Private and public sector have to work together in this type of diseases. There is no a single recipe for ASF, but I can tell you what are the main ingredients, not the recipe, because the situation are so different one place to another that there is not a single recipe. But the most important ingredients is biosecurity, early detection, and fast response. This is the clear point to really avoid the introduction or stop the introduction or have a high and quick detection, to have a good and specific contingency plan adapted to the reality, not make a copy-paste of other contingency plan, and a continued education and training of our veterinarian and our farmers. Now I'm going to tell very few minutes about the vaccine. As you know, several prototypes are already available, but not still commercial. All of them are still under research. We are evaluating, and most of them, at least some other colleagues from the States, some other colleagues from Europe as well. They have already several prototypes using animal trial for the evaluations, and they are really more closest to have a vaccine of ASF than never. In our case, because of the problem that I mentioned to you on wild boar, we are doing two types of vaccine, one for wild boar and other for domestic one. So both of them are running quite well with a very high promising results. But just to summarize, before starting to show I'm going to tell you that ASL legal vaccine are closed, but they're still not in the market. So don't feeling that there are other countries already vaccinating. You see what happened in China, I show you, so be careful. Is non-vaccine already approved. Several prototypes from different research groups are already running, and many of them very promising, but they're still not ready. More animals are in trial, so we need, because of I mentioned to you, for cross protection, for example, we need to vaccinate it and to challenge the animal to be sure that they have cross protection. So we have to do a lot of animals, and that's why they take it a little more time for all of us. So our main objective in our vaccine is security. The second one is efficacy and cross protection. I mean, this is very important. The cross protection is very important, but the security is more important than anything. So we are working, asking for 100% security, and we are around 92 to 99 or 100 efficacy already. However, I mention again, the vaccine is not ready. You see, the vaccine in African swine fever for many years, we know that the inactivated doesn't work, don't induce immune response. The subunit vaccine or DNA vaccine doesn't work either. They induce very weak immune response. The best vaccines, the best that we have better solutions are the attenuated vaccine. The attenuation vaccine we can obtain between a 92 to 100% of efficacy. But the point of this attenuated is the equilibrium between safety and efficacy. And that's why we have to play, in our case, to make safety the first point and efficacy, even if it's lower, but this safety, we're going to be happy. So the project that I am the honor of coordinator is a European Union project. From the European Union opened a call for African swine fever vaccine. Several candidates were presented, and we was the winner with the Bagdiva project. As I told you, it's 3 candidates, the one that we have already. We have several countries from the European Union, as well as from outside of Europe, with Russia, China, and here in Kenya with ILRI, because we want to test in our vaccine in the Facochero and in the Bush Pig as well. The objective of our project is safe and effective vaccine for wild boar and pigs, to develop a DIVA test, and to also show how to use the vaccine in the best way and the different eradication scenarios. So we also have already a very good ASF control with a nice eradication strategy using vaccine. We work in the 3 objectives already in the project. 3 prototypes, as I told you, in the natural attenuated ways, as well as in the elections mutants way. That is for both, for wild boar and for domestic. And the results that we have is 92.86 in wild boar. And it's not because this animal was not protected, it's that he was not immunized. You know, so we have animals that, because orally, we vaccinated orally, and we try to see that the best efficacy with the bait for the maximum immunizations. So we are making increase very much our level with the bait. We have now a beautiful bait that eat it very well for animals, and even they can eat several because they love it. And even if you eat several of these, you don't have trouble. The vaccine is just the same if you take 1, but if you take 10, 11, or 20, or 20, whatever, no problem with that. So our level of protection is already 99.9 and 92.86 in wild boar. And we're going to do a pilot vaccine in Lithuania, other in Kenya. This is what we have in the program, but we also are already evaluating other risk assessment for other areas. And ILRI is to see if we can protect it, because that will be the best way to stop ASF in Africa. And we have already in several in Europe. And this is the status of the different points. As you see, some of them are partially done, but ongoing. Some of them are already finished, but still we are in the progress for at least 1.5 years more. But if you want more information of this, I can invite you for a coffee when you have time to come in and visiting us. So this is our dream, to change the color that is already full, as you can see in ASF, and to have a world free of ASF. I would like to thank you for the invitation to give this talk, to all of you for the participation and to be with us for your company. And I would like to thank also my university, the OIE, the European Union, for funding our research, and my team. This is my ASF team, except the epidemiologists that they are out because they was out the day that we took this picture. Thank you very much, and I am ready for your comments or for your question. Thank you very much.
Thank you, Dr. Manuel Sanchez-Viscano. That was a very good presentation. I want to turn this over to Joe Crenshaw for his talk, and we have several questions that we'll answer here in the next 20 minutes or so.
Okay.
Thank you.
Thank you.
Well, thank you, Dr. Sanchez, for an excellent presentation. And as Tom mentioned, please be preparing questions in the Q&A session that'll follow my presentation. I want to briefly talk about plasma biosafety and efficient pig production. First off, I want to talk a little bit about our manufacturing process for producing spray-dried porcine plasma. We utilize multiple hurdle mitigation technology. And the multiple hurdle mitigation technology is commonly applied in food nutrition or food production. It's a concept that goes to the fact that in many cases, multiple low-level mitigation steps are used sequentially and are more effective at reducing and eliminating microbes than the sum of the individual hurdle. So when we process plasma, there's 4 key steps that are involved in terms of hurdles to help mitigate potential pathogens in the raw material. But first, we collect blood only from animals that are clinically healthy and fit for slaughter for human consumption. So we're not out collecting blood just from anywhere. We're collecting it from veterinary inspected facilities, animals that are, again, clinically healthy and not clinically sick. Another key step is we've implemented is UVC technology. Ultraviolet light C is known to inactivate multiple pathogens, and it's a step in itself that is shown to help mitigate several viruses, which I'll share with you later. But UVC is applied to the liquid as it's before it goes into our spray drying process. Excuse me here, something happened. And another key step is spray drying. Our spray drying process heats the final product up to at least 80 degrees C throughout substance. Even OIE has recognized that 80 degrees C throughout substance is effective in eliminating a lot of list A type diseases, including African swine fever. And so our spray drying process is guaranteed to process that temperature at 80 degrees C throughout substance. And then another step in our process involves post-drying storage. After the product is packaged, we store it for 14 days at least 20 degrees C or higher before it's released for sale. And so to give you a kind of a pictorial view of some of our processes, our UV system is an exclusive UV photo purification system we have developed here at APC. And again, the liquid plasma flows through this system, and this system is designed to allow for a turbulent flow, ensuring all the plasma is treated with the UV light, and then it's passed on to the spray drying system. The spray dryers, again, are computer controlled. And again, we're assuring that it's reaching a minimum of 80 degrees outlet temperature, and this is maintained and continuously monitored. Our post-drying storage at controlled temperature is also another step. And this is a picture of one of our warehouses where in wintertime, we have insulated storage and a heater controlled system with thermometers recording the temperature to assure that it is maintained at least at 20 degrees C for 14 days. We have done several studies looking at the biosafety of plasma where we've intentionally taken a specific virus, inoculated into the liquid plasma, and then either subjected it singularly to UV light, where we can get a log reduction, spray drying by itself, storage at 20 degrees C for 14 days is where we would take the virus and inoculate it on the dry plasma and show a log reduction. And when you look at these viruses, we've tested several different swine viruses, both DNA and RNA enveloped or envelope type viruses, including African swine fever virus. And each step singularly has shown at least a 4 log or higher reduction. And when you look across the total hurdles, we see a very high, greater than 10 log reduction throughout the process. And so when we think about log reduction, when we think about what that really means, OIE and EPA recognizes that disinfectant should have at least a 4 log reduction. That means that it's 0.99% effective in killing or inactivating the virus. If you look at our 3 key steps, hurdles, for example, with African swine fever, again, we're seeing each step has a 4+ log reduction, giving us a total of about a 13 log reduction, which is 99.119 effective in reducing or inactivating African swine fever virus. Some other groups have done some risk assessments. The European Food Safety Agency has recently published a risk assessment for African swine fever, and they looked at several potential fomites, including feeds and feed ingredients. Basically, they concluded that hydrolyzed proteins and blood products ranked lowest of all these potential fomites, regardless of origin or destination. In summary, spray dried plasma is collected from healthy animals, inspected and passed fit for slaughter for human consumption. Blood is collected and processed in a closed system, preventing cross-contamination. Spray drying plant biosecurity ensures that the finished material does not become contaminated with unprocessed plasma. And third-party verification, we've been working with the University of Minnesota as well as EFSA and other groups have evaluated the process and the multiple hurdles used in production and to ensure that the inactivation processes are effective, and have generally concluded that spray dried plasma is a safe ingredient to use. So when we think about plasma and its benefits, it can be used as an effective nutritional health tool to help improve production efficiency. Plasma contains functional proteins that have biological activity beyond just nutrition. The functional protein profile in plasma is very similar to that in colostrum and sow milk. Plasma contains functional proteins, including transferrin, lysozyme, growth factors, cytokines, and probably most commonly known as IgG. And all these functional proteins maintain their activity even after processing the spray dry product. And so our research has shown that collectively these functional proteins do have a profound effect on the animal's immune response and inflammatory response. to help them support animal health and production. When we think about stress, whether it's due to environmental or stress or pathogenic stress, plasma, animals without plasma have to utilize a lot of their nutrients when they're under stress to support the immune system response. When we're feeding animals with plasma and subjecting them to some kind of challenge, whether it's environmental or pathogen challenge, they get through that process much more efficiently, and therefore they're conserving more nutrients then to support growth and production instead of having to support the immune system response. A recent review has shown that when you compare plasma versus other proteins in diets for nursery pigs, you see an incremental improvement in both gain and feed intake up through 40 days post-weaning, even though they may or may not feed plasma throughout that whole 40-day period. So it consistently supports higher growth and intake through that first 40 days post-weaning. And this has been well documented in previous reviews as well. Plasma is very effective even in commercial production conditions. A epidemiological study was done in Canada a few years ago, looking at the odds ratios of plasma in nursery diets associated with high nursery survivability. And what they showed was that plasma in the first or second feed had greater odds, a higher odds ratio of improving nursery survivability than, say, weaning weight alone. Other factors, including biosecurity, disease status, farm management, nursery nutrition, all significantly benefited herd health and survival. And inclusion in plasma in nursery diets certainly had a very strong benefit on health and survival under commercial nursery conditions in Canada. Some people asked if there's a difference between bovine versus porcine plasma. In our research, we actually see very little difference between bovine or porcine plasma. In this study, we had 2 different lots of bovine plasma or 2 different lots of porcine plasma, and I fed it for 14 days after weaning, and by day 35, the body weights were very similar among the plasma sources, no differences in all plasma sources, whether a bovine or porcine origin improved performance over a controlled diet without plasma. We also have done some work and published a few years ago looking at use of bovine plasma in nursery feed programs for pigs that were PRRS positive. This was a fairly large study using almost 1,000 pigs in the study. And at the end of the nursery, pigs fed the plasma program were heavier, significantly heavier, and had reduced mortality as well. In summary, the multiple hurdle biosafety steps we use to manufacture plasma produces a very safe ingredient for use in pig diets. Plasma is a functional protein ingredient that helps pigs to overcome stressful events such as weaning. And bovine plasma performs similar to porcine plasma in pig diets. With that, I thank you. And at this time, we'll turn it back over to our panel, and we'll try to answer questions you may have.
Thanks, Joe, for the presentation. Again, kind of entering now the question and answer period. for yourself and also for Dr. Sanchez-Vizcaino. We do have several questions in the Q&A section, so I do appreciate that from the attendees, and again, continue to add those as we go. Dr. Vizcaino, I think one of the first ones that we had was we talked about the feeding of swill feeding as being a significant potential for transmission. And in China and other locations, we know that they've banned that practice, but how effective do you think the ban is? I mean, is it being implemented from your perspective?
Yes, good question. Thank you very much, Tom, for the question. I think at this moment, we have a lot of virus circulating in many countries, many countries, more than the people even thinking about, because some of the animals are not well diagnosed. And in some areas and some countries, they don't go and slaughter when they have an outbreak. They try to sell meat or whatever. So there is a lot of meat infected already in the world. And this meat can go around the world by boat, by containers, by many different ways to enter. So the possibility to be introduced by this way, in my opinion, at this moment, is the higher one that we have. Yeah.
Very good. Could you talk a little bit about the level of heat treatment that would be necessary to inactivate and kill the virus?
You mean the ASF?
Yes, correct.
It's not too much. It's not too much, but they need to be at 60 degrees, 60, 65 degrees. And for a half hour, 40 minutes. And in that case, if you, for example, take the products, this is a good question, Tom, because we have to give exit to the people that have to do swill feeding because they don't have money enough. And there are people that, family production, etc. So I think it's a good point. And I thanks for the question, because it's true that we have the possibility to inactivate the virus. To inactivate the virus, if you take the swill feeding and you trade by heat, you're just moving like a pup, and you are moving with the temperature for this 40 minutes, 30 hours, depending 70 or 60, and you inactivated the ASF. That will be a good system for these areas where they have to do it. Yeah.
Joe, I got one for you. You talked a little bit about the processing technologies that APC is employing, the multiple hurdle steps. How are those processes validated? How are we making sure that we're monitoring that correctly?
Well, our process is, like I said, we've done a lot of research, doing specific pathogen challenges. Again, we would inoculate, say, a virus into the plasma and propagate it in the plasma, and then feed that to or subject that to our different processes, whether it's UV or whether it's spray drying or even post-processing. Spray dried plasma will inoculate the virus on that, and then we'll go back and try to recover live virus either in a virus isolation process or in type of study, and then calculate the log reduction in that. We've also taken in past studies and actually fed inoculated plasma, raw inoculated plasma with ASF, and fed that to pigs for 14 consecutive days and could not infect them by feed, even with the raw unprocessed plasma, which was a very unique finding. We found if we took that inoculum and injected it into the animal, we could cause the infection. However, feeding it for 14 consecutive days, we couldn't infect the pigs with it. So there seems to be something pretty unique about plasma that helps mitigate something inherent in plasma that may be somewhat antiviral that is preventing animals from being infected when they're consuming it orally through the natural eating process. But a lot of our validation studies that we've done with several different viruses, have been peer-reviewed, published articles. They're out there now, and we certainly can provide those for you to go into all of the details of the steps. But again, University of Minnesota has been working with us over the last 2 or 3 years to validate our processes. AFSA has looked at this information as well, and all the reviewers and auditors agree that the process is very effective.
Very good. Dr. Friscano, I've got one just from my perspective that maybe you can comment on or answer, but as I'm thinking about the difficulties with this virus and the diagnosis, I think there's a time lag from when the onset of the virus is in a population to when it's actually identified. Is there something from your perspective that the industry should be doing better to manage that, say, 10 to 14 day time lag before we actually can identify that a pig has the ASF virus?
The diagnosis of ASF is quick. I mean, as a diagnosis. What is taking a little more time is when you want to genotyping or sequencing or these kind of things where that is taking a little more time. But in general, the diagnosis is very quick. And so a PCR is like a regular PCR for other viruses. And ELISA is also the same time that for other viruses. So the diagnosis in the laboratory is not taking too much time. It's very quick. It's very quick. The problem is that the samples sometimes don't come to the laboratory. The early detection and field is the big problem of ASF, not the laboratory diagnosis. Yeah.
Okay, very good. Could you talk a little bit about disinfectants and from your opinion, your side, which ones you think are very effective?
That's
Dr.
for me?
Vizcaino. Yeah, sorry, Dr. Vizcaino.
I'm sorry. Yes, there is a fantastic disinfectant. Very, very. You have the classical one that was chemical and not even commercialized, some of them that still are working. But from the commercial point of view, they are fantastic disinfectant. I don't want to tell anyone in particular because I promise you there are several and they are working very, very well. And surface and all like, in areas that you think are very difficult, they are very good, very good, very good. The disinfection in ASF is well. The intent of products is not intent of clean and disinfection vehicles that most of the people just cleaning, but don't disinfect it or don't give it the time enough of the disinfection work. That's the problem. But the products are good, very good.
Good. There's another question here from the attendees. Contaminated grain that's been harvested in endemic areas. Has there been much evidence of transmission via that route? And Dr. Vizcaino.
Yeah, endemic areas for us is the worst situation. That's why I am a little worried about what is going to happen in the continent, in American continent, because, there are many people that are going to leave these countries, infected countries, and go back to Euro countries or to free countries, and they don't realize how danger is a product, something that they are eating in the hotel or they are eating in the street and nothing happened to them. Why they're going to be worried to take it at home? And these kind of things are very complicated. We have to really inform well the situations of the people in general, especially tourists, and this is very important. The same happened with the people that work in a container boat, boats that they don't have too much information about diseases or whatever, they don't inform, and they buy products in one country, and they later put the garbage in another country, and they don't realize the risk that they are really offered to a new country. And this is a lack of information. In my opinion, we need more information in general about ASF resistant and ASF mechanism of transmission in the general population, especially tourists, especially boats that do, containers, private flights, these kind of things.
Very good. Dr. Joe, one of your slides had bovine working very similar to porcine plasma with the internal data. That would appear then that the immunoglobulins are probably less important from species to species. How do you explain the results of similar performance between those products?
Well, like I mentioned, plasma is a diverse mixture of functional proteins. And so, the antibody response is not necessarily, the IgG component. When you get into post-gut closure situations, the specific antibodies, I think, have certain ability to go across species in terms of their effectiveness. But you also have transferrin, you also have other components, cytokines and things like that, growth factors in plasma that retain their biological action after processing. And collectively, these proteins, I think, have a pretty profound impact on how the immune system responds to stress. So in some past work we've done where we've injected, let's say, Staph aureus enterotoxin B into the peritoneum of an animal, and that creates a mild intestinal inflammation. But then we're orally feeding either bovine or porcine plasma, and in all these cases, we still see a very strong modulation of the pro and anti-inflammatory response in the tissue levels of animals, not just in the gut, but we see it in the reproductive tissue. We've seen it in the lung tissue as well. That something in plasma is really helping modulate that total inflammatory response across the whole body, not just at the gut. So whether you're feeding bovine or porcine plasma, we see these responses across species. We've done multiple pathogen challenge trials and fed animals diets with either bovine or porcine plasma, same species, porcine to porcine or bovine to bovine or cross species. And we still see these improved health indicators, better growth, less diarrhea or things like that across species, and better survival. So plasma has a very potent impact on how the immune system responds to various pathogens. And it doesn't seem to, again, to be that specific to the antibodies that could be contained in plasma. For example, the PERS study I showed, we were feeding bovine plasma to pigs. We saw better growth, we saw reduced mortality, though you would not find PERS antibodies in bovine plasma. Cattle don't get PERS virus. So again, that's an example of how it seems to work very effectively across species, whether it's bovine or porcine.
Very good, thank you. Dr. Vizcaino, I've got a couple questions for you. Your opinion of the pen side-by-side test, do you think that could increase the sensitivity of some of the trials? And what the challenge here would it be an issue due to the mandatory notification to OIE of a positive result? So I'm assuming this is about field trials,
yeah,
potentially.
I think these tests are very well if you use for the idea of use a test in the field conditions. I mean, there are many countries or many situations or many areas where the difficulties from the sample to reach the laboratory is going to take too much time. And the people have to take decisions what to do with this farm. Well, I close, I don't close, yes, isolated, I don't isolate it, what to do it. So these kind of tests are beautiful for this type of areas where you need a quick diagnosis and to have methods or, to adapt the methods according with the risk. not with the complete diagnosis, because all these positives have to be tested finally at the laboratory for sure, to be sure that this a positive or a negative. But they give you indications. So indications in some places of the world are very important to have in vivo and in situ, because you have to do something. You need to do a reaction to stop the spread of the disease. And you have to base it in something. And these tests are good. They have a very high level of sensitivity, a very high level of specificity, but it's important to confirm. Any new outbreak have to be confirmed in a laboratory, everyone. So I think they are very useful for what they has been designed. But people have to understand that it's not designed to use in a routine basis. And this is important, yeah.
Good. Question on your opinion of surveilling post-harvest pork products in the meat cases. Could that be a better way of than depending on farmers to report the signs to the veterinarian?
You mean how to do an official report?
Yes, correct.
Yeah. Yes, I think this is a big point. This is a good point. Tom, you want to kill me this afternoon because you are looking for a good point. And this is one. This is a good point because, in many areas you said the communication is not fast because the system is not fast. And because the people that really they are seeing the problem and they have already in front of the problem are not listening because are not the official people, and they have to wait for the official people to go there, to do the necropsy, to send to the laboratory. I agree with the question. I think it's very important that we have to simplify the situations when it's needed. And I think that this is important to do it when it's needed, because if you have to do action, it's better to take action. And later the laboratory is going to confirm your action. But you should stop anything that's coming from one laboratory. The laboratory is going to confirm, and it's going to send one guy to be sure that this thing is happening or not. But don't stop the possibility of an early detection. To stop an early detection today in ASF is a disaster. And we should fight against that. We have to do quick detection. Yeah. And later confirmation is no problem. Confirmation. But if somebody is seeing something and they told you, you have to say, hey, let's do it. Let's confirm. Yeah.
Another question for you, Dr. Vizcano. You talked a little bit, I remember in your presentation, about the challenges with sending the samples in, either in swabs or in things with alcohol, because it inactivates the virus, but you can still find it from a PCR standpoint. Are there other process methods or other testing methods that would allow the detection of live virus in those samples at this point?
Yeah. Most of the samples that we receive at the laboratories are live sample. Most of them, the tissue of the animal, the blood of the animal is infected animal. But the problem why we found this a solution is because there are places and countries and areas that they don't have the container enough safety to traveling with them. And there are many companies that don't want to put on their plane products that, they don't know if are infected or not, but they know it's not safe. And that's why I think, and to have these solutions, when we put this solution already in information to everybody, is not thinking in countries that they have good container, good communications, it's not. It's for places where they don't have this security and sending a product outside. So to make it easier and to make it safety, this kind of transportation is what I think is very good, because it's very sensible either. They take on the surface of an infected area, and I am sure that they're going to be positive at the laboratory, but they don't have to send that tissue or blood that is really high contaminated. And this is the point. I am thinking more in the IATA, in the airplane companies and all these things, and in little towns and faraway places. This kind of thing is, in general, the diagnosis are many possibilities, but the most important is to use the one that is more adequate for each scenario and give it to each scenario a solution. And I think the sponge give a lot of solution in many scenarios and countries that some people don't know that exist, but they exist. And they have trouble to find a safe container, or they have trouble to be accepted in one company, in one flight company, to put the product to fly. And this is the truth. And so is that the way?
Okay, very good. I always have very tough questions for you. Here's another one. We talked about the ASF vaccine. I mean, the challenges with the genetic variability with the ASF virus. What do you think is the fastest time to get an approved ASF vaccine? And do you think it would be available in big quantities? And I mean, it's a question, obviously, but no one has the answer to, but I'd like your opinion on what you think.
My opinion is that we're going to have vaccine for ASF. The question are two. It's going to be safe in all conditions. And the second one is, it's going to immunize the different virus variability that are in the different continents, or it's going to be a universal vaccine. It's going to be a regional vaccine. It's going to be a universal vaccine. This is the two questions. And these two questions need a lot of in vivo experiments. And that's why it's going to take it a little more time to have the answer. But the vaccine is already. I mean, vaccine is a product that vaccinated with a protection of 100%, 92%, and safety. We have this product. What we don't have the complete answer is, this product is only for Europe, or it's for Europe and for most African countries, or is also valuable for Asia? That's the point that we are running on.
Okay, very good. Thank you again. Joe, maybe we'll jump over to you for a question. Let's say separation and application of various plasma protein fractions that you talked about. I mean, is that a further way to optimize the plasma effect?
Well, certainly internally, we've looked at several fractions of plasma, and at least in our research suggests there's certainly certain fractions have a pretty good biological activity alone relative to intact plasma. And so that's something, in development, and, we have, in other industries, developed, say a serum fraction or a Ig concentrate fraction in some of our other applications for use, say in milk replacer or colostrum supplements and things like that for calves. That's available today in those industries. But we continue looking at different fractions and different components and feel there's some good activity there. It comes down to the bottom line of, can we produce it economically? Can we make, and does that fit into the market we're trying to sell it into, where it's practical and easy to use? So that certainly there are components you can fractionate further down from plasma. As a whole, we still get a little bit better response using the intact plasma than we do these other fractions by themselves. So it's still a work in progress, I would say.
Dr. Vizcaino, I have another question here for you, and I found this interesting as well. So you showed that there could be an ASF vaccine that could be administered orally. Obviously, then that gives us some chance of efficacy in wild boars. Has that type of study, or is that application being tried now in Europe already, or are we still under development with that?
Yeah, we have the only way to vaccinate the wildlife is orally. We cannot go by injection, intradermic or intramuscular. So that's why we are working in the wild boar vaccine with the bait, not with injection, because we design a system to feed the animal in different areas with this bait and replace the bait when they are finished until the vaccinations will be complete. and all animals will be well vaccinated. Why to do orally? Because it's no other way to do in wildlife. And there are some experience that we have here in Europe with classical swine fever. When Germany was affected because of the wild boar, they also used the Chinese strain for classical swine fever as a vaccine for the wild boar and by bait the animals. And only in a couple of years, we finished with the disease in the wild boar. So we saw that that's happened, and that is very efficient in some particular viruses. And we already described it that in African swine fever, oral immunization is possible. We found that oral immunization is possible. And we found that the overdoses of vaccine, it doesn't affect the problem. So we are quite safe with this vaccine. And we're thinking it's going to be very useful for the wildlife problem. And the wildlife problem, as you saw in my presentation, is the worst that we have in Europe and probably in Asia as well, even that they still don't really relate it, the problem, but it's a big problem. So I am completely sure that this is the best way for wild boar vaccination, yes, orally.
And to follow up on the wild boar situation in Asia, you showed the maps with the endemic population of wild boars, like in the China region. Do you think that the government there do they acknowledge that is a big risk, or are they doing some studies to try to understand the potential safety risks with wild boar specifically in China?
I don't know what they think. I really don't know, because I don't think that they noted already how important are the wild boar in the spread of the disease, or probably because they have other mechanisms of spread that are more important, even like the swill feeding, the use of blood, all these kind of things. And that's why they don't give it too much attention to the wild boar at this moment. And Europe is just the contrary. We have very high biosecurity. We have good knowledge of our farmer to avoid the entrance, but we cannot do nothing with the swill feeding. And the wild boar infected with the swill feeding, and they jump into the farm. I mean, this is that's the problem, that depending on which other risk you have. In Europe, the higher risk is the wild boar in the European Union. And other areas is not the wild boar, it's the swill feeding. For example, in some East country, it's not the wild boar, it's the swill feeding. And in Asia, I think they have both. They have the swill feeding and they have the wild boar, but they still don't notice. They don't give it the importance that yeah.
Gotcha. Another question, is there a website that this person can read more about the virus isolation process?
Yeah, the virus of African swine fever from a natural way only is growing up in leukocytes or macrophages of pigs. So you need to have that in your laboratory to growing up. So you need to have donors of leukocytes, so blood or macrophages of lung. You need animals that will be donated of these tissue cells, because are the ones that the virus adapted very quickly. We also have some cell line that the virus can growing up, but the wild virus is much better leukocytes or macrophages. This is the best way. So from blood, leukocyte donors, or from lung, macrophages donors. And this donor, you purify the macrophages, you separate the macrophages, you put in a tissue wall, a plate, and you just put the virus, and the virus replicated very quickly, and leukocyte and macrophages. This is the best way to do it. So you need to have donor in your laboratory, testing donor to be sure that are negative and no problem. And so you can do it there, yeah.
Very good. Here's a question, I can field this one. Do you anticipate spray-dried plasma availability to fluctuate based on slaughter numbers? And I would say yes. I mean, we see that globally with our manufacturing facilities in certain areas of the world. When we see ASF spikes and a reduction of pig numbers, places like China or places in Europe, yes, we definitely do see a different availability of the processing of the blood, because there's just low animal slaughter numbers. Again, this is why APC focuses to be a global company with our 17 plants, so we can access plants from a regulatory perspective kind of help satisfy the demand in the various regions. When incoming plasma may be low, we can take advantage of production in other regions of the world. Another question for Dr. Vizcaino, and I think this goes back to the vaccine availability. Do you have a best possible case timing scenario of when they're actually will be legally available? I mean, can they be administered now within Europe? When do you think they might be available for China or elsewhere?
I think that in the European Union, we never going to vaccinate the domestic pig. This is our policy with other infectious diseases similar to ASF, and we never going to use in domestic pig. I think in the European Union, we're going to use it for wild boar most, and probably in West, I mean in the East Europe, probably also in domestic, and some particular areas to stop the spread of the disease. But in other countries, is the only way that they have, especially if you have wild boar infected and domestic infected with no biosecurity, with backyard, with all these things, you need to vaccinate this. This is the Chinese system. China never eradicated any disease. They use vaccines because with the vaccine, they are working well. That's why over there was very common when the vaccine, illegal vaccine, start to be used, because at the beginning they detected that the mortality was reduced. So what they need was meat, and they don't care at the beginning too much if the meat that they have already is contaminated or not. They are meat, and these kind of things are important. So every part of the world is different. So probably the vaccine that today will be not used in the European Union and other countries will be fantastic. So I cannot answer in a global situation. I can answer in some particular example, as I told you, China and Europe. China have tradition vaccinated everything, and they believe in the vaccine, not in the control and eradication. And they don't care if they have a vaccinated animal that produce slowly, that they're not vaccinated because it's no disease. They prefer the vaccine even if they lose a little money, but they still have meat to sell. And we cannot do that. So you see, the diseases are the same, but the countries are different. So when you work in viral diseases like me, you have to be a little psychiatrist and psychologist, because it's not only to know about the virus, you have to know the application of the virus and different systems. So you need to understand the sociology of these countries if you want really to be effective. Because if you only thinking on the virus, you are not effective around the world. You could be effective in one area, but not around the world. Yeah.
Very good. Appreciate that. Another question for you, Dr. Vizcaino. Could you talk a two-part question? So are insects and rodents, do you consider them a big risk for transmission? And the second part of the question is, on a farm, if one barn is found to be infected, is eradication of the whole farm needed?
Tom.
Baited question, I know.
Okay, let's start with the insects. We know that the virus replicated in Ornithodorus. We know that. So if you have this type of soft ticks, you probably have to be sure that it's not Ornithodorus, because in Ornithodorus, they bite the animal, replicate it, increase the virus, and infect it. And not only that, they can be infectious for more than 5 years. So the virus keep alive in this animal for 5 years, not bite anybody, this insect. So be careful with that, because it's a very resistant virus. So it's possible, and it's important to know what kind of, especially the bland, what we call soft ticks. If you have soft ticks, be careful with them. We have to evaluate it very well, which kind of soft tick is. This is in relation with the first question. The second question, I don't remember, Tom. What was the second question?
The question was, if ASF was found on a particular site that maybe had multiple barns.
I got that. That is the question that made me many people and many places. If I have an early detection and I kill the animals that are sick and I disinfected well and I have everything clean, why not keep it the rest? And I said, what are you doing to be testing that you only have the virus in here? How do you know? How do you know that this animal, the person that has been working with you was not moving there or was not moving at the other place before you have a clinical picture? And most of the cases is that people are moving, not only in one part of the farm, is moving all over. The guy of the food, the guy of the many movements. So if you are infected in one area, you will be infected for sure, that for sure. Because the virus, you at the beginning is not explosive. ASF virus is not explosive. You don't expect it to have 100 dead the first day. You're going to have 4, 5, 6. And by the time you detect it, you put the virus with your shoot in many different places. The second point that is important in relation with that is that you cannot not make a good starting again of production if you are not completely sure that the place is disinfected, perfectly disinfected. So, and the only way to do that is, of course, with the sponge. The sponge will help you because it's many surface to evaluate it. But the most important is to use sentinel animals. And the people, piglets, you put a couple piglets, like 10 piglets or 11, depending on the size. And the piglets move all over and freedom around. And you monitoring these piglets with serology and with PCR to be sure that they are not getting virus at all. This is the best way, because I promise you that the question that this guy asked you is the question that the Chinese are asking themselves many years, and they don't believe it, and they have continual reinfection. And what's happened in China? You reinfected, but they sell that. So they don't lose so much money. So they lose more money if they are fortified, the control, the virological control, etc., because they normally take 40 days with no production. And so in that particular places where you sell the meat because they need meat and they don't want to import, in that case, people said, okay, for me it's better. Okay, my animal are not too good. I spend more time to produce the kilogram, etc. But I sell it. And I don't care if I reinfected myself in 45 days, because in 45 days, I have to clean and disinfect it and testing. I'm going to be dead because I don't make money enough. And that's the problem, you see? So it's not a good answer for everyone. It's every situation, it's a little different.
Yeah, agreed. And I think that's the challenge we see here right in the Western Hemisphere now that we have ASF back after 40 years in the Dominican Republic and Haiti. How in your opinion, how should they manage that? I mean, I know that they've been trying to eradicate some pigs and along those lines, but from a risk profile perspective, what should be the right way to approach that in those two countries? Your opinion?
In my opinion, yes. In my opinion, situation where you have so many backyard and so much virus circulating, if you keep the backyard and the virus circulating, you're never going to finish with the disease. And sooner or later, even the very high biosecurity industrial farm are going to be infected, because the amount of virus circulating is going to be so high that at the end, even the wonderful biosecurity is going to be, infected as well. So the best thing is really to have a very strong biosecurity in the industrial farm and protect it a lot and be very severe with the backyard farms and the family farm to be sure that there is no one with virus there. Even supply the pigs from the industrial farm, but not keep it there people unless we are sure that there is no virus circulating in the country. But these solutions that from the virological point of view and epidemiological point of view is the logical one, is not the logical one from the sociological point of view. And from people that are very poor and they need to have this pig and they don't trust you, they say that you're going to bring not only 1 pig, 3 pigs every week. And all this sociology is what make it very complicated. So the control of the diseases in most cases is not only the problem of the disease itself, it's the environment, what the diseases involve. And in some places, the authorities, the people that have to take the decision, they understand me perfectly when I explain you like I explained to you, but they cannot afford that from the political point of view or from the sociological point of view. And this is the problem. When you combine science with sociology and with human feeling, it's very complicated.
Yeah, it's a very difficult, challenging situation from all perspectives. I agree. Well, we've only got a couple minutes left here. Joe, I had just one more for you real quick here, but it was a question about, let me go back to where I found that one at. Here we go. Can you just talk briefly about the ability of spray-dried plasma to impact the immunity and in its relation to the zinc oxide scenarios that we see in Europe and the rest other countries that are coming?
Yeah, certainly. There's a recent publication from the Danish. In Europe, they're going to eliminate the use of high levels of zinc oxide, for helping control E. coli related diarrhea. Starting in 2023, I believe, or late 2022. Of course, they all have already eliminated a lot of the in-feed antibiotics use as well. So the Danish are now recommending using at least 5% plasma in that feed in the absence of zinc oxide availability. In the plasma, we've done several challenge trials over the past few years, looking specifically at E. coli and both K88 and F18. And when we're feeding animals plasma in the feed, we see less diarrhea, less mortality, less and better growth rate in pigs fed plasma under an E. coli challenge scenario, even with or without antibiotics, and or with and without zinc oxide. So again, plasma is certainly positioned well, I think, to fit into those scenarios for sure.
Thanks, Joe. One more question for you, Dr. Vizcaino, on the Q&A side of things. Goes back to the swill feeding in a lot of the Asian markets. Do you see a credible collection treatment system whereby swill feeding could be made safe for an ASF risk? And what would that look like?
Yes, there are countries like Japan, for example. In Japan, they keep the swill feeding as a normal way of feed animals, but they have to be treated in several places. So the Japanese has produced on different areas of pig production, especially family pig production and big yard. They produce this system that they inactivated the product and they give it to the farmer to use it. It's swill feeding, but it's inactivated swill feeding. So it's possible to do, it's cheap to do, it's not very expensive, and is one of the best way to solving a social problem and a cultural problem. I think it's good, that question, and there is solution for that in countries that are doing that normally. And I have to ask you one favor, Tom. I have to pick up a train. I have to pick up a train. So,
I totally agree. So we're going to wrap up here. I want to thank our speakers, and especially Dr. Vizcaino, because I know you have a very busy schedule. So thank you very much for the time.
Thank you very much, everybody. Thank you, Tom. Thank you, Joe. Thank you for the invitation. Have a good day. Bye-bye.
Safe travels.
Bye.
Thank you very much. Again, I think we had a very good webinar today. I appreciate the attendance of everybody and the questions that were there. I think we'll provide a link to the recording for those that want to go back and review some of the information and also the question and answer period. So with that, we're going to end a little bit ahead of time, which is fine. And again, appreciate everyone's attendance. Thank you very much.
Thank you.